The summers are really getting hot, and this piece of paper is really helping me to get rid of this hot summers. But have you imagined that the same paper can be used to harvest solar energy? Yes, we in this video will tell you how this paper can be used to harvest solar energy, and this energy can be used and converted into chemical fuel, that is hydrogen, which will be used as a clean future fuel and is being used in various nations. So basically what we will be doing with this paper, we will be creating artificial leaf by coating a photoactive material on this paper in such a way that that can actually harvest the photons, and further this material helps us to energize based on photo excitation, and then this material will get photo excited and the charge carrier generation will take place at this electrode, and then the holes which are at the valence band of this material will actually participate in water oxidation, and the electrons which get excited to the conduction band, they will be channelized to the counter electrode, which is a platinum electrode, where the hydrogen production will take place and water reduction will take place at the cathode, that is the counter electrode. So based on this we get two products at two different electrodes, and the hydrogen which will be produced at counter electrode, we can store that hydrogen, and that is the clean future fuel and is being used in various applications. So based on this unique idea of using this paper as an artificial leaf will be demonstrated in the coming video. Okay, so the discrete elements for this experiment will include the paper electrode, which is the kind of anode, and this is actually a material which is photoactive, and this will actually act as an artificial leaf for solar energy harvesting. So next element is the cathode, which is a platinum electrode, and this will be used to complete the circuit with anode and cathode. And this is the electrolyte, which is the normal water, and this will be used to actually have ions in the reaction. And after this we have the element is the solar simulator. So the standard solar simulator is of AM 1.5G spectrum, and this is used to mimic the natural sun, and the power density of this solar simulator is 100 milliwatt per centimeter square. So next is the potentiostat, which is the last discrete element which will be used in this setup. So this will actually measure the amount of current generated using the anode and cathode setup that we will be showing in the coming experiment. So here the graph characteristics we will get with respect to voltage and current. So after assembling the anode and cathode and the electrochemical cell, this is the whole assembled electrochemical cell, and now we irradiate our anode with the solar simulator light. So as this mimics the solar sun, so what happens when the photons, actually this is a photon excited process. So the sun, being the renewable source of energy, produces photons, and those photons excite our anode, which is a paper electrode, and then this anode actually participates in water splitting reaction, wherein it splits the water into oxygen and hydrogen. So basically with the photo excitation, the anode, it gets excited, and then the electrons, they channelize from the valence band to conduction band, and the holes which are in the valence band, they actually participate in water oxidation, where they split water into oxygen plus H plus ions, and the electrons which gets channelized using this electrical contact to the platinum electrode. So thereby they produce the hydrogen at the cathode, which is the platinum electrode here. So this is the complete water splitting reaction, and here you can see hydrogen getting evolved at the counter electrode, and this is the way how we can use paper as an artificial leaf for solar energy harvesting, and thereby producing hydrogen as the clean future fuel. Okay, so now as you can see hydrogen getting evolved at the electrode. So thereby this produces huge electrical current, which is being recorded with this potentiostat at the system, and the current produced reaches up to several milliamperes, and this can be recorded using this potentiostat. So as we have demonstrated in the video, the paper can be used efficiently for splitting water and producing hydrogen as the clean energy fuel by the solar driven process, in which we are using solar energy as prime renewable energy source. In that way, this hydrogen which is produced can be used in various sectors, be it an industrial sector, be it a public sector, or in any electrical grids as well. So the near future is basically a clean hydrogen future, in which we contribute to zero carbon emissions, and so we wish you good luck. We welcome hydrogen as the clean future fuel.